What's up, Cal gang? Welcome back to statics. So let's solve this problem. We're basically just trying to break these vectors, force 1 and force 2, down into Cartesian vectors. So right now we're given the magnitude, right? We see that it's 40 pounds at 30-degree angle. This one's 50 pounds at a 20-degree angle. But we want to break that down into Cartesian vectors, which is the stuff with the i's and the j's. So let's go ahead and do that. Let's look at our force 1 first. So here's force 1, right? It looks like this. We know that the hypotenuse is 40 pounds. When it says that your magnitude is 40 pounds, that basically means the hypotenuse is 40 pounds. Now let's break this down into vectors. So our vectors would look like this. We have force 1y, and we have force 1x. Right? So this is the x and y components, the I and j of this vector here. We know it's 30 degrees. And we know that's the right triangle. That's what's true about vectors, right? So we're trying to find the sides of this triangle basically, and this is system trigonometry. So this is trig. Let's go ahead and solve the trig, right? So what do we want to find first? Well, let's try force 1x first. So what do we know? We know the hypotenuse, and we know the angle, so we can use sine or cosine. So what do we know about sine? Well, sine of theta is equal to opposite over hypotenuse. Oh, so if we're trying to find opposite, we know the hypotenuse, we know the angle, so let's go ahead and do that. So we know that sine of 30 for this triangle is equal to opposite, just force 1x over the hypotenuse, which is 40 pounds. So we can move the 40 pounds over to get that 40 times sine of 30 is equal to force 1x. Now, of course, we can solve for this, and here we get that force 1x is equal to 20 pounds. Cool. So we found this force 1x, so let's go ahead and find force 1y. So we want to use cosine this time, maybe. So cosine of theta is equal to adjacent over hypotenuse. So we're going to do force 1y over hypotenuse, which is 40 pounds. And we know that this theta is 30 degrees for this triangle. So we can move the 40 over to get 40 cosine of 30 is equal to force 1y. That's a y, yeah. And then force 1y is equal to, let's see, 34.6 pounds. So now if we want to write this as a Cartesian vector, all I need to do is do this. So we're going to say force 1 is equal to, with the little vector on top of it, force 1x, right? We're going to say 20 I. So the I hat says that this is the x direction. And then this, that's plus the 34.6, sorry, j. The j says it's the y direction. And this is in pounds, right? Yes, so there's our answer for the first force. So now I need to do this basically for the other vector, and we've solved the problem. Grab my cap. And I lost my eraser too. All right, let's go ahead and do the next vector. I'm trying to get rid of all that. So the next vector is force 2. So let's go ahead and draw that over here. So we know that force 2, its magnitude, its hypotenuse is 50 pounds. And we can consider it like this. So this is F2x. And then you see that force 2, y, is negative, right? It's going in the negative direction. That's because it's in quadrant 4. Quadrant 4 always has a positive x direction, but a negative y direction. So let's go ahead and figure out what these are going to be. So you see how we solved the first one doing the whole sine and cosine thing, but the trick is you can simplify it a little bit, and you're going to want to learn this for statics. So let me teach you how to do it. So if you want to find force 2x, right? What are we going to do? Well, we want to lay it down. If we say that we know that this is 20 degrees, right? So this is the adjacent one. So when you're adjacent, you know that's going to be cosine. So for adjacent, we're trying to lay it down flat. We know that we need to use cosine. So we're simply just going to take the 50-pound hypotenuse and do cosine of 20 degrees. And this is how we find force 2x. I don't know off the top of my head, of course. Can't read my own handwriting. I think that's 42. Maybe I should double check that, but I think that's probably correct. It's probably not 47. Okay, and then force 2y, we're going to do the similar thing. So force 2y is equal to, we're going to take the hypotenuse, always start with the hypotenuse, and then this time it's opposite. So it's opposite from the 20, so we're going to do sine, because sine is opposite. Sine of 20 degrees. And that gives you 17.1 pounds. So one more trick, remember that this is in the negative direction, we're in quadrant 4, so we need to make sure that y is negative. So we're going to just put a negative next to this. So negative 17.1 pounds. So if we write force 2 as a Cartesian vector, we're simply just going to do 42.0 I minus 17.1 J pounds. And there we go. We solved the problem. So thanks for watching the video. Check out my next video for a little bit more challenging of a problem. And yeah, check out my statics playlist. Subscribe. It helps me a lot. I really appreciate it. And I'll see you in the next video. Peace.